Hey everyone, my name is Monique and I am working with the University of New Brunswick St. John campus as a fourth year nursing student to teach a little bit about med math. I have some other videos and today we're going to be doing the drug dosage calculations part 2 and we're going to be focusing on giving a liquid medication, whether that be IM, SC, PO. We're going to be focusing on the liquid aspect of things. So by the end of this video, hopefully you will know how to calculate drug dosage calculations for liquids. So what do we need to know before we start this video? There's some important things. We have to know the rule of under 1 ml versus over 1 ml. So if you're giving under 1 ml of a medication, we are going to be rounding to the 100th position. And the reason for this is I have a syringe up here, is that it's calibrated to the 100th position. So right here I have 0.41 of a ml of this medication. If we're giving over a ml though, the syringes aren't calibrated to go to the 100th, so we're going to the 10th position. So here I have 1.8 mils of a medication. So that's what you need to know, under versus over 1 mil. Let's start out with some more basic information here. So when we see a vial of medication to administer, we're going to see the amount of drugs per a certain amount of mils. Sometimes it's per 1 mil, sometimes it's per 2, and in this case, as you can see here, it's 4 milligrams of ondansetron per 2 mils. This also has the conversion for 1 mil, but we're going to pretend that it doesn't, so let's just get rid of that. And we're going to do that math on the next slide. So, like I said, what does this mean? What does it mean when you look at a vial and you see these things? It means that for every 2 mils of this medication, we have 4 milligrams of ondansetron. So it can be broken down further when it's given in more than 1 mils. So let's find out how many milligrams are in 1 mil. Since we're looking for milligrams per mil, we can do exactly what it says. So this drug is 4 milligrams in 2 mils of medication. So we want milligram per mil. There's nothing canceling out here. That's exactly what we want. So we know that there are going to be 2 milligrams per 1 mil. So that's how you do that. You're just taking your milligrams, dividing it by the amount of mils, and then you're going to find out how much medication you have in 1 mil. Let's go right to a question. So the physician orders amoxicillin 10 milligrams IM. Amoxicillin is supplied as 125 milligrams in every 5 mils. How much are we going to administer? So we have 2 ways of doing this. Again, I'm going to start out showing you the formula. So I've broken it down. So we have our D, or our desired. We want 10 milligrams of amoxicillin. We have 125 milligrams, and our quantity is within 5 mils. So we can draw this out and figure out how much we're going to be administering. Again, if it's under 1 mil, we round to the 100th. If it's over 1 mil, we're rounding to the 10th position. So let's do our math here. So we have 10 milligrams. That's our desired dose. That's how much we want to give, over what we have, which is 125 milligrams, times the quantity. So we're timesing it by 5 mils. So if we do this calculation, we are going to get 0.4 mils. So it worked out really great. There is no other position. There's no 100th. It's just plainly 0.4. So you're taking your 10, dividing it by 125, and then you're multiplying it by 5, and we are going to be giving 0.4 mils IM. So we have another way of doing this. So dimensional analysis, so we can cancel out units. So with this one, we're going to say how many milligrams are in each mil. I want you guys to be able to find this. It's really, really, really important. So we are doing 125 milligrams. We want milligrams per mil, so we're just putting it over our 5 mils. And our answer is going to be 25 milligram per 1 mil. So why I think it's really important to do it this way, this is the way that I prefer it, but again, whatever works for you is what you need to use. So the reason I like to do this is because now I know that there's 25 milligrams in 1 mil, and I know that I'm giving 10 milligrams of the drug. So I'm going to be giving less than 1 mil. Since there's 25 milligrams per 1 mil, I'm going to be giving less than that, which is great. So if we're canceling out units, we want to give 10 milligrams. Let's cancel out these units. We're looking for the mils that we're going to give. So we are going to cancel out our milligrams for 1 mil. And our answer is going to be the same as it was before there. It's going to be 0.4 mils. This is how much we're going to give our patient 10 milligrams of amoxicillin IM. So let's move on. I'm going to kind of go through these, not quickly, but I'm just going to be giving examples basically is what I'm going over. Okay, so now that you have seen both ways to do it, find the way that works the best for you. Let's move on to our next order. So we have atropine. Let me change my colors. Atropine. What we want, what we're giving, our desired dose is 0.6 milligrams. What we have, so we have 0.3 milligrams, and our quantity is 0.5 mils. So every time, like when you see your vial, it's not necessarily going to say per 2 mils or per 1 mil. It can also say per half a mil. So that's really important to know, and that's why these calculations are so important. So let's write out our formula. We know that our formula is D over H times Q. So we want 0.6 milligrams divided by 0.3 milligrams, because that's how much we have. We're multiplying it times our quantity, which is 0.5 mils. So when you do this math, you're going to find out that you're giving 1 mil of this medication is going to equal 0.6 milligrams of the dose. So if I get rid of this and we just simply cross out our units, then we have, it's the same thing. We have we want to find out how many mils we're giving. So 0.6 milligrams times, we want to cross out our units, so 0.3 milligrams, and we want to get to mils because that's how much we're giving, 0.5 mils. And the answer is always going to be the same. It's 1 mil. That's how much we're giving. So when you're drawing it up, you don't need to worry about rounding. It's an even number there. Okay, next question. So we are giving we want to give 7 milligrams via the NG tube. So 7 milligrams PO of morphine via the NG tube. So that's our desired dose. How much do we have? So we have 5 milligrams, and that's per 1 mil. So this is our desired, this is what we have, this is our quantity. So if you just stop and just take a second to look at the question, we're giving 7 milligrams, our supply is 5 milligrams per mil. So we know that we're going to be giving over a mil of medication. So if we have to round, we're rounding to the 10th position. It's just something like you kind of want to take that step back and look at the question. You can make sense of it a little bit more if you do that. So let's have our formula, D over H times Q. So we have D, 7 milligrams, over 5 milligrams times 1 mil. So if you do your math over here, as I have done, you will find that we are going to be giving 1.4 mils to equal 7 milligrams of the medication. That's how much we're going to be giving to our patient. So again, it's rounded to the 10th position, this one here, and that's how much we want to give. So we can cancel out units if you would like. Do that in blue. So we have 7 milligrams times, we want to cancel these out, so it's 5 milligrams per 1 mil. And our answer is going to be the exact same. We're giving 1.4 mils to equal our 7 milligrams of morphine. So these are just a few different ways to do it. These are pretty basic calculations, but if you can get this down pat, it's going to help you for all the other ones that you do as well. And they get a little bit more complicated as we go. And if you continue to watch the videos, you'll see that.